driven by light, power for the future. This is a flagship intelligent manufacturing base at the heart of OSDA's N-type photovoltaic strategy. Jiangsu Hongshu New Energy Company Limited, spanning approximately 430 mu, with a total investment of over 5 billion renminbi. It is planned as a 6 gigawatts N-type TOPCon cell manufacturing base. Here at Hongshu, every high-efficiency cell is a result of precision engineering and advanced innovation. Step 1. Texturing. The journey begins with texturing, removing surface damage, residues, and impurities, while forming a pyramid light-trapping structure that suppresses reflection and lays the groundwork for stronger current generation. Step 2. Front boron diffusion. Through low-pressure boron diffusion, precise p-type doping is achieved. Boron atoms uniformly penetrate the silicon matrix, forming the core PN emitter and establishing the heart of photoelectric conversion. Step 3. Post-boron treatment. High-temperature oxidation deepens the boron junction as an oxide mass grows in sink. Slow annealing repairs lattice damage, lowers surface recombination, and strengthens PID resistance. Step 4. BSG etching and rear side polishing. BSG residues on rear side and edges are precisely removed to ensure front-to-back insulation, while mirror polishing enhances rear reflectivity and minimizes optical loss. Step 5. LPCVD deposition on the rear surface. Ultra-thin silicon oxide and intrinsic polysilicon are deposited through LPCVD, creating a passivated contact structure that reduces metal-induced recombination loss. Step 6. Rear phosphorus diffusion. Rear phosphorus diffusion creates the potential difference needed for selected electron transport, further refining the cell's electrical performance. Step 7. PSG removal and cleaning. PSG residues are completely removed, reinforcing insulation integrity. RCA standard cleaning follows, eliminating contaminants and porous silicon structures to further reduce surface recombination risks. Step 8. Front side ALD passivation. An aluminum oxide layer is then deposited on the front side through ALD, repairing dangling bonds, lowering defect density, and delivering field effect passivation that elevates open circuit voltage. Step 9. Front and rear PCVD coating. PEC coating adds a silicon nitride anti-reflection layer, where hydrogen passivation repairs defects, preserves passivation quality, enhances PID resistance, and improves light transmission for higher current and stronger long wavelength response. Step 10. IDC plus AI intelligent process control. With an industrial-grade IDC data hub and AI-driven process control, every stage is fully traceable. Core parameters are dynamically calibrated, micron-level defects precisely identified, driving higher conversion efficiency, greater yield, and stronger batch consistency. Every process is a pursuit of the limits of photoelectric conversion. Every detail reflects our uncompromising standards for performance and quality, built on intelligent manufacturing, driven by technological excellence. OSDA Yancheng Hongshu base, advancing with the world towards zero carbon future.